Okay, so we are on now. Okay, good evening, everyone. Okay, welcome to our October edition of the virtual airport tour. Okay, for those who are not sure about what APOD is, okay, APOD actually is stand for Astronomy Picture of the Day. Okay, this is a website provided by NASA and Michigan Technological University. Okay, every day there are dozens or hundreds of photos submitted from everywhere in the world to this website, and they will pick a special one to feature for the daily photos. Okay, so in our airport tour, we will go through selected photos and explain about what the photos mean. Okay, so that other than we just look at the photo, wow, very beautiful, then just forget about it. So we are going to look into some technical, some theory, or some information, interesting facts about the photos, so that we can learn something from the photos. Okay, so let me introduce our guest today. So our presenter will be Dr. Chong Han Yu. Okay, he's the president of our Astronomical Society of Penang. And Mr. Lai Hong Chun is a committee member of our Astronomical Society of Penang. And also we have a guest, okay, here, Dr. Derek Rim, okay, who is a amateur astronomer, okay. And myself, my name is Michael, and I'm the committee member of the Astronomical Society of the Penang. Okay, so I'll pass it to Lai. Cool. You may start now.
Yes, so good evening, everyone. Good evening, Michael, Dr. Chong, and Derek. So I'm Lai, and welcome to the airport tour session tonight, or this evening. So I've shared the screen. Can you all see my screen on the first photo? So let's start the session with the first photo, which is the photo of today, the 1st of October. So good to know one thing is today is also Halloween. So happy Halloween to everyone, to all our audience, to those who are celebrating. So there is a theme today, Halloween. So the astronomy picture of the day, of today, is about Halloween. So this picture is actually some, I would say, is sort of a posters, right? Discussing about Halloween and relating Halloween together with astronomy or the universe. So when we talk about Halloween, usually we remember about something about haunted, about ghosts, about makeup, you know. Kids like to make up, and then even adults also make up. And I was in Beijing last year in our student dormitory, and then even for all the foreign students, especially those from Europe, from America, they dress up, they make up, and then they dress up, they go, they have party, and then they celebrate Halloween. So it's kind of a very big festival celebrated in the Western world, I would say. So of course it's today, so children will go to request for candies, all right, and we don't have chance to go door to door to request for candy today. So we have something, right? We do something related on the same theme. So we have something on Halloween. So we talk about something haunted, right? So in the universe, there are something, we said something haunted, right? So the first thing is dark matter. So it's like we say those ghosts, you know, you can feel it, or some people believe they exist, but then they can't see that. So the first thing that you can't see in the universe, but it actually exists, is called the dark matter. So it's the first posters over here about dark matter. So dark matter, it actually emits no light. All right. So it's in we call the invisible range in the electromagnetic spectrum. And something interesting to know about the universe, about this dark matter, is the whole universe, on what we know on the whole universe, only 5% consists of matter, which we about, I would say, 90% are fully explored, or we are still exploring, knowing about this matter, studying a lot on this matter. It's only occupied 5% of the universe. And Another about 23 to 24% is consists of this dark matter, and the rest are dark energy. So this dark matter, right? We know it exists, but then we still don't manage to see it. So dark matter. So it actually fits the theme Halloween. All right. The second one is called the Galactic Graveyard. All right. So when we say, I always like to, when I conduct classes on astronomy, talking about this stellar evolution, I like to make this statement is like, actually, all the stars is like human being. You were born, and then you will grow from young age to adult, and then you will get old, get sick, and die. So the same thing, all the stars will die, right? It's like human being. This is like the natural law. So stars were born, stars will die. So after they die, all right, so we have this called the Galactic Graveyard, all right? And I'd like to introduce a bit on this. Is we have the term called the dead galaxies, all right? Dead galaxies are actually the galaxies that stars formation have stopped, all right? We have a lot of galaxies in the universe, and then we know that every galaxy is almost every day or many of the times, all right, we have these stars, new stars are born and their stars are dead, all right? Just that we don't manage to see it every day. We did not discover that, but it is actually happening because there are billions of stars in the universe. So there are new stars born, there are old stars dying, or new stars become adult stars. So this term dead galaxy means in the whole galaxy there are actually no new stars are formed. So slowly, eventually, the whole galaxies will die, right? All the stars inside the galaxy will get old and then will die. So slowly will become like a graveyard. We call it the Galactic Graveyard. And the third one is about the gamma rays, all right? Gamma rays is also quite related to Halloween. Why? Because gamma rays, one of the source of gamma rays, all right, is from neutron stars and from pulsars, right? Pulsars, they give out gamma rays. So we know that pulsars, neutron stars are actually the dead of big stars or giant stars. So these big stars, they die, they undergo supernova. Either they become a black hole or become a neutron star. They die and then become a pulsar or become a neutron star. So neutron stars, pulsars, they give out a lot of gamma rays. So we have gamma rays is also quite related to the theme. And just a little bit add on about this gamma ray is gamma rays have high energy. All right. So if this gamma ray penetrates through our body, all right, it's not like this alpha and beta ray particles that can be blocked by thick layer of lead or thick layer of concrete. Gamma rays have a very high energy, which will penetrate through our body and will cause damage to our body. So be careful with gamma rays, all right? Especially those are playing with this radioactive substance in the lab, all right? Be extra careful when you have to handle with gamma rays. All right, so this is about today's photo. So let's proceed to the next one. All right.
Okay, I think Derek has something to say about Halloween.
Yeah, just quick add-on, okay? Just sharing experience, like one way for astronomy outreach that we can do, you know, if you notice people in your community trick-or-treating, put out a telescope, aim it at Saturn or, you know, Jupiter or whatever is visible, and, you know, let them do trick-or-treat and say, okay, to get candy, look at Saturn, look at Jupiter or the moon, you know, for all that matters. Yeah, I did that in the States once, and it was actually quite popular. I got to be known around the neighborhood as the astronomy guy after that. So it's actually quite fun. Anyway, just thought I'd add that. And I don't know whether Malaysia is a lot of people celebrating, but a possible activity that can be done one day. Yep, and that's it.
Okay, next.
Okay, next. So we will go to the next picture. The next photo, the next APOD photo. We go
make
to
the phone bigger. Make the phone bigger, people can see.
30th of October, which is yesterday's APOD photo. So this APOD photo is about the Mars, right? This year is, we say, in the astronautics world, all right, in the, or we call the interplanetary mission world. Mars is we have everyone is almost everyone is having this Mars fever, right? We have three, I think the record of the year, or for the recent 10 years, we have the record, which is we have 3 missions to the Mars, right? Early from July to, the whole July, from early July to end of July, starting from the Arab Hope mission, all right? That one is a simple orbiter mission, and then we have the Chinese Tianwen mission, and then we have the American, I forgot the name. We have the American mission, Perseverance mission, all right, sending a lander to the lander and rover to Mars. So Mars, everyone is having Mars fever. And why Mars is so popular this year? Because we are having Mars opposition. I think somewhere mid this month, 2 weeks ago, I think 13th of October, right? We are having Mars opposition. That means we are very near to Mars, right, compared to the other times. And Mars opposition happens about every 2 years.
26 months.
That is 26 months. That means 2 years plus, right? So we have Mars opposition. So that means Mars is quite near to Earth, right? So this is a photo about the Mars, all right? And I think many people will question about this is why this Mars looks so different this time. Because this Mars, this time is, let's see the caption over here. It said is overexposed for frames of the photos. So that means this photo is shot. Okay. This photo is shot on almost a full moon. That means the caption below it says the full moon is almost the full moon.
6.
So the
Full day past full moons.
Overexposed planets glare reduce the orbit. Sorry, where is it? I read this. The yellowish glow, or the yellowish glow outshine other stars throughout the night. Okay, because it's a near Halloween full moon on the sky. So maybe I match a bit. So on the caption it says the near Halloween full moon on the sky. The strange yellowish glow outshine the other stars throughout the night. So it appears slightly brighter. And this is a composite image. That means it's take many shots and then it combines together. And Mars, we know we have 2 moons, all right, or we call 2 natural satellites. So one is called Phobos, the inner one, which is the orbital distance is about 1.4 to 1.5 the Martian diameter, the diameter of Mars, and we have a bigger another moon called Deimos, which is having a bigger orbital period. All right, bigger orbital period. That means it's further away from Mars. All right. So this is a composite image. It means it's taken many images and stacked up together. So you can see at different time. All right. You can see for Phobos, because it's very near to Mars, so the orbital period is very short. All right. One Phobos year. That means the Phobos, all right, orbit one round Mars is about 7.6 hours. That means it's less than a day. It's like one third of our Earth day. So you can see over here, the Phobos motion is very clear. All right, at 10 o'clock at night is at this position, but almost 2 hours later is already you can see a very clear motion, an obvious motion of Phobos. But for Deimos, it's relatively static because the orbital period is longer. It's about 30 hours, 30.3 hours. So the motion of Deimos is less, let's say, less obvious. All right. So this is a composite image. All right. And bear in mind one thing is you will not, when you capture the image, you will not see this orbit. This orbit is added in manually. All right, is digitally added. Okay, is edited so that you can see the orbit of the natural satellite of Mars. All right, so this is about the photos for 30th of October. All right, so shall we proceed, or any comments from anyone?
No question.
Proceed to the next one, which is on the 28th. I have chosen 28th of.
Wow, so nice.
Okay, the Lobster Nebula. Right. So I hope everyone already had your dinner. All right. Haven't had your dinner. This is a good option. Lobster. This nebula looks like a lobster. Okay. So imagine this is the two big clam with a lot of flesh inside. Tastes good. All right, and it's well cooked. It's red. So this is we call a Lobster Nebula. All right. And for Lobster Nebula is also, we have another, the scientific name, or we call it NGC 6357. All right. The common name we address it as a Lobster Nebula because it looks like a lobster. So this is located, all right, neighbor of our Milky Way. That means it's not inside the Milky Way. And why I like to pick up this APOD photo is because this Lobster Nebula is famous. Famous for what? Famous with a lot. It has it produces a lot of massive star. All right, it forms a lot of massive star through this Lobster Nebula. And the largest, all right, the largest star generated, or the largest star formed in this Lobster Nebula is, we call it the Premise 24. Premise 24 number 1. And the interesting thing is, initially they thought that the Premise 24 number 1 will be the largest star discovered because it have about 300 times the solar mass. That means the mass is 300 times of our sun. And only after that they realized that it's actually a triple star system. That means there are actually 3 stars, and they have saw 2 stars inside this Premise 24 number 1. So this is about the Lobster Nebula. And let's have a look about the caption. All right. It says the overall blue glow near the inner stars forming region results from the emission of ionized hydrogen. That means this blue region over here is actually emission from hydrogen ionization. And also the surrounding nebula, okay, the surrounding over here, all this surrounding, hold a complex tapestry of gas, dark dust, stars still forming, and newly born stars. So that means around the whole nebula, there are a lot of stars forming, and the whole nebula spans about 400 light years and lies about 8,000 light years away from the constellation of Scorpio. So this nebula is very big. All right, we see it. All right, we see at the photo is like from here to here is like maybe this is very small, and at the night, even if you manage to look through a telescope, it's actually a very small dot. Okay, through your naked eye, you will not be able to see this. All right, but then, in fact, distance, okay, across here from this point to this point, okay, is a few thousand light years. All right, according here is 400 light years. Okay, from this point to this point is 400 light years, and then it lies 8,000 light years away from the constellation of Scorpio. That means it's very far away from Scorpio. All right, and this, I think Scorpio is around this season. We could see Scorpio, right?
Coming up soon.
Coming up soon. So you're able to see.
Oh no, should be going away soon. Sorry.
Going away, right?
Yeah,
and
but now it's Orion coming up.
Yeah, so that means, yeah, this, you can see this nebula for
Another few
another
weeks
period
or
of time,
months.
and then slowly it will be going down, and we have to wait another year. So let's proceed to the next one. I'll go for 27th of October. Right, it's this a Venusian volcano. That means this is an artist's impression. It's not the actual one, it's not the actual photo, but it's an artist's impression. So we know that we see Venus many times, right? We see Venus many times, and then we know that Venus is we call the Earth twin sister, and is quite active. It's a well-known active planet. We have a lot of volcano, right? And it's famous with its acidic atmospheric condition. You have an acidic atmosphere, okay, and it rains like Earth, but the rain is acid rain, all right? So this is the artist's impression. So we know that they have volcano, and whether the volcano in Venus actually looks like this, we are not sure about it. Okay, we don't know. But then based on the volcano on Earth, all right, so the artists imagine that the volcano erupt. Okay, volcano eruption on Venus is about the same like Earth. So this is the artist's impression. This is not the real one, okay, the real volcano eruption in Venus. All right, so this is about it on 27th of October. And let's proceed to 25. Now 25 is a very interesting image, right?
Halloween, huh?
Yeah, another Halloween. So on the beginning, I discussed a bit on the dark matter, dark energy. So this is a simulation, okay? The simulation result of the universe. So all the black one is actually the dark matter, the black line. So the distribution of this dark matter in the universe is a lot, and it's like spider web everywhere. They are everywhere. And the bright one is matter, right? Is bionic matter. So it might be a stars, or it might be a whole galaxies, or whole star system inside, all right, or clusters or galaxy. So this is a simulation. And why this dark matter is so important, okay, I like to point out a bit, is because this dark matter is the leading explanation of why galaxy rotates so fast. We know our galaxy is rotating, and it's rotating very fast, but rotating at such high speed, why all the star system can stay inside the galaxy? Because one of the leading explanation is because of this gravity by this unseen dark matter, and also why galaxy orbit cluster so fast, why gravitational lenses are so strongly deflect lights, and why visible matter is distributed as in both local universe and also we call it the CMB, cosmic microwave background. So dark matter explains all these phenomena. So this is a simulation, because as I mentioned just now, dark matter does not emit visible light, does not emit all the electromagnetic spectrum. So we know it exists, but then we don't have the technology to detect it yet, right? It's unfair to say that we cannot see it or what, but then I would say a better way to say it is we don't have the technology to detect it yet. So this is by simulation. That means computer simulation, numerical calculation. So this is the distribution of dark matter in the universe. So all the yellowish point, the small point, all this small point doesn't mean that represents a small point. It might represents a star system or represents galaxies. All right. So this is about the simulation of the universe and the distribution of dark matter. Okay. So any comments from anyone or from the audience?
No question.
We proceed to the other one, which is the last one before I hand over to Dr. Chong. So it's about the globular cluster. Okay, this globular cluster, okay, globular cluster is a group of stars. All right. Each small points over here represents a star, or even more than one stars. Right. So these globular clusters is called globular star cluster 47 Tau. Okay, is located in this constellation Tucana. And this whole thing is a globular cluster. It consists of hundreds of thousands of stars. All right, so that means every small dot over here is actually a star or a star system. So a lot of stars over here. And one interesting thing is this is the second brightest globular clusters we can observe from Earth. All right, the brightest globular cluster is Omega Centauri. The second one is this 47 Tau, and it's not very far. All right, it's just 13,000 light years away, and we can spot it by naked eye. Of course, by naked eye you will see as one dot, right? A star, like a normal star you see in the sky. Okay, but you take long exposure with a very powerful telescope, then you can manage to capture this image. Right, there are hundreds of thousands of stars in these globular clusters. And where does this globular clusters located? Is actually in the Milky Way. All right, it's located in Milky Way, and it roams around the halo region. So that means the Milky Way. We know we have a Milky Way. We have the disk, we have the bulge, and then we have the arm, the spiral arm. So this globular cluster is not located at the arm. It's not located at the bulge. It's not at the center, but it's on the halo region. All right, so it roams around the halo region. 100,000 of stars roams around this halo region of the Milky Way. All right, so this is about it. This is about that from me. So any questions or any add-ons before I hand over to Dr. Chong?
Yeah, I'd just like to add this 47 Tucana is actually very easily visible if you use binoculars. So I first saw it in Fraser's Hill, and it's right beside the Small Magellanic Cloud. So 2 in 1, you can get the Small Magellanic Cloud and this globular cluster at the same time. Okay, and then another thing that very interesting with globular clusters is if you imagine you're sitting on a planet right at the core, and you look up into the sky in the globular cluster, there'll be about 30 stars that are brighter than Venus. Okay, and Venus is like the third brightest thing in the sky after the sun and the moon. So if you see a bright star in the evening sky, that is most probably Venus. And then imagine 30, average 30-ish of them scattered throughout the sky. It's probably a very spectacular sight to imagine. Right, so I think that if there are people interested in observing, use a pair of binoculars, 7 by 35, 7 by 50, 8 by 40, 10 by 50, all great. Okay, to observe astronomical objects, and this one is a particularly nice object to observe. Okay, that's all I'd like to add.
Okay, Lai, there is one question, okay, about
Yes.
the dark matter. So there is one China dark matter particle explorer named Wukong. Is there any result from there, or you know about the mission?
Yes, that is a mission. I think 2 years back. I think 2017, if I'm not mistaken. Wukong. It's actually a dark matter and dark energy exploration. So they actually received back some data, and they claim that it's a big discovery. It's not a big discovery. It's like a one step ahead. That means they have go one more step further on this dark energy discovery. They actually get some results on that, but then I did not read through in details what are their discoveries, but then they said they managed to, I see they actually did publish, I think in 2018, that means 1 year after the mission, they did actually publish some results on the findings, which they claim that they have they have moved one step forward in the discovery of dark energy in the universe. Yeah, any add-on from Derek or Dr. Chong on this dark matter or dark energy thing?
Just want to add on a bit to what Lai said. The history of dark matter. Dark matter was started in 1935. Professor Fritz Zwicky from Switzerland So they were studying the rotation of the Milky Way and nearby galaxies. So it was postulated in 1935. Until today, not detected, but it confirmed it exists. And then that was what, 85 years ago, no? And then about 1980s, 40 years ago, dark energy, even more mysterious, all right? So it was postulated. And then now the scientists are confirmed that all exist. So sorry, boys and girls, ladies and gentlemen, you and me, the McChicken you just ate is only the 5% real matter in the universe. The 95% of the dark matter and the dark energy, we don't know what it is. All right? So now they know that about 68% dark energy, 27% dark matter, only 5% normal matter. All right? So in other words, sometimes when we go and do stargazing in USM, I will tell my students, universe, where are you? Universe, where are you? I look at the sky. My students say, no, we are on the universe, you're saying Earth. I said, no, we are now standing on the Earth. You look at the stars, it's only 5% of the known universe. The other 95%, people still don't know. So I added by saying that, sorry, even Professor Stephen Hawking is so stupid. Mankind is so stupid. Can only discover what is 5% of the universe. If I meet an alien walking along the Batu Perigi beach one night, first thing I'll ask is, what is dark matter? What is dark energy? Please tell me. Yeah.
And then they will tell you no such thing. It's something else. It's totally something else.
Yeah.
I have a question actually. So Dr. Chong, has this there's an alternative theory to dark matter, of course, and that is the modified Newtonian dynamics, right? Has that been disproven? And because I think what fascinates me about dark matter is like it's a proposed idea, a proposed theory that kind of wants to explain the unexplained gravitational rotation rate, right? Yeah. But it's to me it's still like I'm not follow up everything, but is it proof?
So actually, like what we know is
Newtonian dynamics, right?
Yeah, dark matter has the same property of normal matter, that it exerts gravity. That's the only thing. But what is dark matter? We don't know. For example, they say it could be the WIMPs, could be the machos, and so on. So we still don't know. So until today, nobody has found out what is dark matter. Although they're trying for 85 years, And out of it, 1980 come out even more mysterious dark energy. And dark energy is what? Dark energy is anti-gravity. Dark energy is the one that pushes the galaxies apart. So in other words, what I'm saying, the universe is really, really mysterious. Right? So for example, like if the what you call the galaxy can bend the light, the made of the real matter. Similarly, the dark matter also can bend the light. All right, that's the only similar thing that we know about dark matter, got gravity. But other things than that, we don't know what's dark matter. So I would say anyone who comes up with a theory of dark matter can be proven, hopefully Nobel Prize in Physics. Dark energy, faster Nobel Prize in Physics.
Then they'll complain again why Nobel always go to physics and astronomy.
Yeah.
I think it's been like three years in a row, right? The Nobel Prize of Physics goes to astronomy.
Yes.
Yeah, so some people are not feeling good about it.
Well, they should have been an astronomer then.
All right, I think we continue from here.
Yeah.
So
I enter now live.
Yes, so I'll stop this sharing, and then I'll hand over to Dr. Chong. So thank you, everyone.
Okay, thank you. Bye.
Okay, I'll just go now. Can see my screen,
Can?
Okay,
Yeah.
So, first of all, we welcome, of course, our Derek. Derek, of course, is in Bangkok, whereas Lai and Michael and me we are from Penang. So just to let our what I call Derek know. So since 1986, we also have been doing weekly Friday night stargazing in USM, and since 2016, we have been doing weekly Saturday night stargazing in Kapal Singh Drive in Penang, and we are now having what? Our withdrawal symptom, not because of no enough blood, no stargazing. Everyone will want to do stargazing, cannot do because all lockdown. So what we do is take our telescope and put it in our garden, somewhere nearby, and watch like a lone ranger. So we hope that finally everything will open soon, no more lockdown, and we can really enjoy the universe again. All right. So now the next one we go would be October 21st, APOD. Okay, so this is the picture for this October 21st. Before I continue, I would like to say that I first saw APOD in 1995 when it came, in June. So from 1995 until now, we have about 9,200 pictures already uploaded in APOD. Every day, one picture. So this is our supernova in 25, in NGC 2525. So NGC actually is our new general catalog. All right, it's a wrong meaning. Some people thought new general catalog means last year it came. No. 1888. Many years ago already, more than a century, by our Emil Dreyer, a Danish and our British astronomer. He came up with, compiled this catalog, all right, which is this NGC, New General Catalog, so this 2525. So basically you see here, it is actually a spiral galaxy, all right, and it is about, in the constellation of Puppis. Puppis actually is a constellation in the south, and in Latin it means the roof of one of the rooms on top of a sailing ship. Remember a sailing ship? And on top of it, you have a roof that's called the poop deck. So that's called the Puppis, all right? So this is a spiral galaxy, all right? And then you have, for example, in a spiral galaxy, you have here a bar here, a bar spiral, and then you have the spiral arm. And the spiral arm are normally, you have the pink color, the blue color, and the red color. So these are the younger stars. And these stars sometimes called the population 1 star. Population 1 star means they are heavy in metals. So for example, in astrophysics, we know that in astronomy, metal doesn't mean iron. Of course, in astronomy, it's a metal. But in astronomy, metal means anything element heavier than helium. So what is heavier than helium? Lithium, beryllium, carbon, oxygen, sulfur, all those are metals. Only hydrogen and helium are not metals. So here in the spiral arm, the stars, of course, you have hydrogen and helium, but also rich in metals. Lithium, beryllium, carbon, oxygen, and so on, plus, of course, iron and gold and silver also. And here in the core, all right, you have the population 2 stars. The population 2 stars are poor in metals, meaning they have hydrogen and helium, all right? And usually, the population 2 stars are much older than the population 1 stars, all right? And interestingly, they say that right over here, you have here a supernova, right? So that means this. There are many amateurs in the world also. Every night they look at the sky. They try to find a new supernova. That means months ago they were observing this galaxy NGC 2525. No bright star. Suddenly, this star will brighten up 1 day to 2 days, 3 days, 4 days, until about 3 weeks later, very bright. So they detected a supernova here in this one. And this one you see, I'll make it bigger so you can see is by which organization. All right. Okay, NASA and ESA. Okay, ESA is the European Space Agency. All right. And this is scientist M. Zamani, Dr. Zamani, of course, works in ESA and Hubble. For example, usually Hubble picture is not only owned by NASA, no? It's owned by Hubble, by NASA and ESA. All right. So, and this one is ARIES, is an American scientist. SCSCI is Space Telescope Science Institute, the Hubble Space Telescope, Johns Hopkins University. All right. So the Hubble Space Telescope is run from Space Telescope Science Institute, Johns Hopkins University in Baltimore. And Baltimore, you know, is a city just next to Washington, D.C. All right. And this is the SHUS team. So this is they observe a supernova appearing in this spiral galaxy. Right. And of course, this is not a star in the galaxy. This is a foreground star. So this star here is in our galaxy, Milky Way. And if you look at me here, this star has got 4 spikes, you know. All right. That means NASA used a telescope. There are 4 veins. There are 4 legs holding the spider of the secondary mirror. That's why there are 4. But this is not. There are many things holding the secondary mirror, and this is the supernova. All right. And behind it, there's another spiral galaxy. So the universe is really, really amazing, right? So the next one we go to is 20th of October, 22nd of October. Interesting, remember, big news, you know? All right? Voila! Ayo. So this is what, remember the what they call tagging Bennu, the American spacecraft OSIRIS-REx sent by NASA, and of course, working with the University of Arizona and Goddard Scientific visualization stadium. Remember, America got NASA. NASA got many centers. One is the Goddard Space Flight Institute. So this is Goddard, all right? And so on October 20th, the Osiris-Rex orbited the Bennu, all right, the asteroid Bennu, and landed on it and come on an arm and hit this 30 centimeter diameter disk, about 1 foot diameter, hit the Bennu surface for a few seconds and suck up a lot of material. So they estimated about 60 grams of material from asteroid Bennu was collected by the arm. And later on, this will go into Osiris-Rex, all right, and put in a container, and it close the container, and after that it will come back to Earth. So this is called a touch and go type sampling event, all right. So our asteroid Bennu is looks like a diamond shape. I'll show you afterwards. It is about 500 kilometers, not 500 meters in diameter, half a kilometer in diameter, named after Egyptian deity. Remember the ancient Egyptian, a lot of deity. So this ancient deity of Egypt is about rebirth, all right, rebirth lah. So this one is beautiful because you see, for years and years, scientists are waiting to get direct samples from Mars. They try to get, right? So we know that on the Earth, some of the meteorites that fell onto Antarctica, India, Egypt, Southwest USA, the meteorite that land on the Earth's surface confirmed came from Mars, right? I mean, years ago, an object hit the surface of Mars, threw away a lot of materials from Martian surface, orbited the solar system for many years, and later on landed onto the Earth's surface. Michael, can you hear me?
Can.
So landed on the Earth's surface, all right? So mankind has been waiting for years and years to get direct sample from Mars. So the one that fell on Mars, from the asteroid hitting, the one is indirectly, something hit Mars and the material thrown out and came to the Earth. So now one of the main missions, remember, the Chinese, what they call Tianwen-1 mission, is they want to dig some of the sample on Mars and keep it on Mars. The future Chinese mission on Mars will recover the capsules with the Mars rock and bring back to the Earth. Just like the American Perseverance mission also. They also will get samples of Mars, put in the capsule, and in the year, in about 10 years from now, another NASA mission will go to Mars and bring back the capsule. So they are waiting to get samples from Mars. But this is from asteroid Bennu, right? And this is not the first time. Remember, many years ago, Japan sent the Hayabusa spacecraft, orbited and landed on the Japanese named asteroid Itokawa, and brought back the sample from Itokawa back to the Earth, landed in Australia, right? And also recently, the Japan sent a second mission called Hayabusa 2 mission, also orbited another asteroid named after Japanese, Ryugu, and also landed on it and took a sample back to the Earth, all right? And it's going to land in Australia near Adelaide in 6th of December this year, 2 months from now, all right? So if they can bring back the sample from Bennu, it will be the third sample return mission from an asteroid. So this is really great. But let's look at another one earlier, 10 days earlier, is 12th of what they call October, where you see the Osiris-Rex landed on Bennu. So I'm going to play a video, make it smaller, all right? Osiris-Rex orbiting the Bennu, and then later collect. So this was earlier before it landed, all right? So you look at Bennu now from Osiris-Rex. Half a kilometer in diameter. This lump of material is called sigmund. Okay, so now it seems they have found about 60 grams of the material put into the container of this Osiris-Rex on the way back to the Earth. And some of you may say, what's so great of the material of the asteroid or and so on. But remember, we know that you have the asteroid belt between the orbit of Mars and Jupiter. There are actually millions and millions of asteroids there. And this is one of the things which the NASA and many people have been discussing for many years, including what they call this top science fiction author, asteroid mining. So when they bring the sample back from the two Japanese mission and this American mission, they will see what are the materials found on the asteroid. Hopefully they have large quantities of important what they call substances like iron, or like recently they found that one of the asteroids may have gold, a lot of gold. So this is it. So very interesting. Huh? So we're waiting for this to land. So when will this Bennu land? In 2023. In 2023, another 13 years from now, the Osiris-Rex will land back on Earth, but it will land in Utah, in a place in America called Utah. Whereas the Hayabusa 2 will land in a place called Woomera, near Adelaide or South Australia. Woomera is a place where many years ago the British tested the atomic bomb. You know? They tested the atomic bomb in Australia near to Adelaide. You know, right? So we continue. October the 21st. Okay, I read. Wow, so nice, Cintasui. Okay, so a night sky vista from Sardinia. Sardinia, we know, is an island on the west part of the peninsula of Italy, just below France and just next to Corsica. All right, so this is a panorama of the Milky Way, and it is here taken by our Thomas Rowinsky. He's an astrophotographer from Slovakia, right? In Central Europe, a small country called Slovakia, next to another small country called Czechoslovakia. But previously, Czechoslovakia and Slovakia was one country, Czechoslovakia, but they broke up already. So this is taken by what they call Thomas Rowinsky from Slovakia. They went to Italy, went to Sardinia, and this is the two friends of Thomas, all right? And Cintasui, you see, wow, so nice, all right? You see the arch of the Milky Way, you can see the obscuring, the dust of the Milky Way, Andromeda Galaxy here, California Nebula, all right, in Pisces, and then Orange Belt and Betelgeuse. And you can also see here the Barnard Group also, very nice. And of course, you can see meteors here, all right? And the meteors here, they say is a lot of, this is a meteor shower. This is a January quadrantist meteor shower, right? We have seen a few times in USM. In the whole night, we saw about 200 quadrantists, you know, in one night for the quadrantist meteor shower in early January every year. So this is beautiful, right? Okay, so this is from Sardinia by our Thomas Rowinsky.
There's a Polaris on the left.
Okay, you are also, yeah, they say. So we know that the Polaris is here because this is the pot of the open where you put your curry, this is curry of the Big Dipper, the handle. So here you count 5 times. This is the Polaris. This is the Big Dipper. So this is the celestial pole. So these stars can see here throughout the whole night, all right? And this is so nice, all right? This is our this. So this is, of course, no telescope used, just using 60 exposure with a camera and just add on, all right? So yes, previously in the airport pictures, they even give details on what telescope they use, how much exposure they use, what processing time. Now, no. Now they assume that any astrophotographer put a picture, they're expert already. You don't have to explain what telescope they use, what technique they process. They only give you the result, all right? That's it. The next one is on 19th of October. I really like this one, all right? So this is by our, what they call NASA, you know, JPL, Jet Propulsion Laboratory, Caltech, also, of course, JPL Caltech is part of NASA. And the Southwest Research Institute is a privately funded research institute, all right, Boulder, Colorado. And the Marlin Space Science Institute, all these are private companies, no? But they're doing top cutting-edge research. And the processing is by Kevin McGill, all right? Kevin McGill is actually a software engineer from Los Angeles, all right? And they also got the music. Later I play the music. So basically it's Juno, Juno. Remember, 2016, NASA flew a spacecraft called Juno, entered into the Jovian system, orbited around Jupiter, and passed by the moons from time to time. So this is a picture of our, what they call this, Juno fly by Jupiter. And we know here you have the Great Red Spot, all right? So this one is, remember, Jupiter is like many of the outer planets, the gaseous planet, mainly hydrogen and helium. Remember, the composition of Jupiter is similar to the sun, you know, 75% hydrogen, 25% helium. But the hydrogen on the surface of, on the clouds of this Jupiter is molecular hydrogen. Helium also molecular helium. And a bit of methane, ammonia, hydrogen sulfide, and water. And depending on the amount of methane, ammonia, hydrogen sulfide, and water, it gives the color to the atmosphere of Jupiter. Let's play the video. Hope you can hear. So Juno is orbiting, not orbiting, past a flyby of orbiting Jupiter. Now, previously, you cannot see a picture like that. Look at the cloud tops of Jupiter. So clear. So clear. Can hear the music, Michael?
Yeah, I can.
Okay, the dark one is the empty space. Great red spot not come. After 2 minutes, also only great red spot will come. Wow, you look at the detail, so nice. Yo. Now, this is not a great spot. This is not a great spot. It's a bit long, but no choice. Nice video. Now, this is not a T2 video, huh? Every single frame is correct, huh? Okay, it's coming now on the top left. Top left coming. There you are on the top left. It's actually an anti-hurricane has been blowing on Jupiter for the past few hundred years. Anti-hurricane, huh? 2 Earths can be swallowed inside the great red spot. And you can see also a lot of the small oval here. A lot of oval here you can see. Okay, I just stop now because another 3 minutes to go. So basically, this is what you see, a nice video. I am very sure that this video plus other images of Jupiter taken by Juno, some of the PhD students in America are working on it. So they are doing their PhD studies with this, you know. All right. So we continue on the October the 17th. All right. October 17th. Cygnus, Bubble, and Crescent. Of course, this is in the constellation of Cygnus by our Wissam Ayub. Wissam Ayub is actually an amateur astronomer from Abu Dhabi, United Arab Emirates. Of course, these people are very lucky. Why? You just travel out of the capital city. What you have? The desert. The desert is very dark. All right. So this is the earlier one. We have the bubble nebula. But the more important is this one. This is the so-called Crescent Nebula. All right. This is a Crescent Nebula, and this is because there is a star that died. It is giving off tremendous stellar wind, very powerful wind. blowing like a hurricane, and it's making this bubble expand, the Crescent Nebula, all right? And in the center, you have here a wolf red star. The stars got many names. Wolf red stars are stars that are very bright, and when they get older, they are very powerful winds coming out. Wolf red star. So this is our Crescent Nebula, all right, in the Cygnus, the Swan. All right, we go back, we go to the next one. October 16. This is nice. All right, October 16. Planetary Nebula Abel 78. Abel is a famous American professor astronomer, all right, and taken by our Bernard Hubel. Bernard Hubel is an amateur astrophotographer from Austria in Europe. And what we are seeing here is, this is a nebula. Okay, this planetary nebula means it's a star similar to our sun. Near the later part of the life, it's not a supernova, much less milder than a supernova explosion. It will puff off puffs of gas and dust. All right, it will come up. You form not a donut, a spherical bubble. Here there are two, inner one which is green and blue, and outer one which is red. All right, and of course this is a star in the foreground galaxy. All right, and this is here. You say that. Okay, so we know that the stars, for example, inside here, the dying star will give up the light, will energize this expanding nebula, and this gas here, the electronic, what they call transition line of the atom will be excited and will emit, in this case, blue light. So in astronomy, we know that sometimes you look at the nebula, for example, the one that Lion mentioned, the Lobster Nebula, you see the blue. The blue normally is oxygen, all right, lines. The green, surprisingly, the green is hydrogen, and the red, which is sulfur. So by studying the different color of the nebula, we know what are the elements in the nebula, giving off what are the lines. And we know that every single element on the Earth's surface and in the universe has a lot of lines, Take, for example, the sun has mostly hydrogen. The hydrogen itself, that means the neutral hydrogen. Hydrogen means H1, neutral hydrogen. Ionized hydrogen is H2. So the H2, the ionized hydrogen has 25,000 spectral lines. So this is the spectral lines of the sun. The spectral line of the sun is called Fraunhofer. So hydrogen also got 25,000 lines. So what about sulfur, oxygen, calcium, magnesium, silicon? So basically you have millions and millions of lines. So for the scientists, when they collect the spectral lines of this nebula, they have kepala pening. But don't worry, computer software, the computer software can analyze every single line. Which in this case, this is a emission line, right? There are two types of spectral line. One is the emission line, and another one is the absorption line. So by studying the emission and absorption line, you can know a lot about the object. We go to the next one. October 14. Wow, so nice. Once you see this, you know, it's in the Rio Ophiuchus, all right? Okay, and this is from a guy from Iran, Amir Abulfat, all right, from Iran, and so beautiful. So remember, Ophiuchus constellation is something called the 13th constellation, because part of Ophiuchus constellation cuts the plane of the ecliptic. So this is an Ophiuchus constellation. And so what are all these? These are actually the emission nebula in blue, in red, and so on. And this is the absorption nebula. And a lot of what is what? The molecular clouds. All right. So we know more about this thing. This is a real Ophiuchus star system. All right. And it is not very far away from the star Antares. All right. And you see here so much nebulosity. So this here you have a globular cluster, and basically you see these are all molecular clouds, So if you wait long enough, somewhere from here, maybe 1,000 new stars will be born, And now you have discovered until today 4,000 exoplanets in the Milky Way galaxy. So many exoplanets will be born here. And you look at so much stars here, so fantastic, right? So by studying the the spectral lines of this. This is for Emission Nebula, and this is Emission Nebula, and I think maybe part of it is actually a Reflection Nebula, and this is a Absorption Nebula. So you can see all the three types of nebulas here: emission, reflection, absorption nebula. Right. So in the view of figure, this is one of the most beautiful places in the Milky Way. Right. So this shows that full of molecules. So now the astronomers have used optical astronomy and infrared astronomy and radio astronomy. They have found that the molecular clouds in the Milky Way have thousands of molecular species. They have found ammonia in the molecular clouds. All right. They have found what they call methane in the molecular cloud. They have also found ethanol, which is alcohol, pure alcohol, in the molecular cloud. For example, many years ago, I gave a lecture in USM that in a certain part of the Milky Way, there's a molecular cloud got a lot of ethanol, alcohol. And I told my student, how much alcohol in this molecular cloud equivalent to 10 trillion swimming pool of alcohol, pure alcohol. Well, you only can go to that thing, right? And there's another nebula. I told them that, girls, some of you like to put lipstick. Lipstick is it? Do you know that lipstick got a certain organic molecule? And this nebula here has trillions and trillions of swimming pool of lipstick you can get there. So many of the molecules on the Earth, you can find in the molecular cloud. Benzene, yes, all right. Ethanol, methanol, a lot are in space, all right. So this is about real ophiuchus, what they call molecular clouds. The next one will be.
So can I ask a quick question?
Go ahead.
Yes. Can we say that these are kind of like possible building blocks of life? You know, like how life form on planets. There are all these carbon compounds.
Yes, you hit the jackpot, Derek. Exactly. So here, for example, we will say that why is it in the meteorites that fall onto the Earth, the scientists have immediately collected the meteorite and cut through the center of the meteorite, not at the side of the meteorite. It will be contaminated by Earth material. From the center of the meteorite, they found there are organic material. There are amino acid, ethanol, and all kinds of. The only thing they didn't find is the ethanol, the DNA. They've not found because the original molecular cloud floating in space, the dust and the atomic and the molecular and the absorption cloud, they are made up of all these organic material. So when they collapse to form the star, and also to collapse to form the so-called planetesimal. The planetesimals are starting from a pebble-sized object, and then the gravity will accrete more, become a size of a car, a house, size of Penang Island, size of Malaysia, size of Earth. So this planetesimal will then form the planet, and the planetesimal are from the molecular clouds, and they are made up of organic molecule. So that's the interesting thing, right? So the fact that these molecular clouds got elements that are heavier than hydrogen, the metals lah. So carbon is a metal, lithium is a metal, beryllium is a metal, iron is a metal, titanium is metal, uranium is a metal. They're actually cooked in the center of the star. They actually fuse from hydrogen to helium, helium to carbon, oxygen, and finally the nuclear fusion will stop at iron. All right, and then the star like Betelgeuse explode, supernova will fuse from iron to lead to uranium to plutonium and even higher. So in other words, the fact that there are heavy elements here, these elements cannot be formed in the Big Bang. The Big Bang only produces hydrogen and helium only, and a bit of lithium, beryllium, no carbon. Immediately after the Big Bang, you cannot have your McDonald's, you know. McDonald's, the drumstick got chicken, got carbon. Carbon was fused in the center of the star. So the fact that you look at the molecular cloud, you know, these clouds, the atoms here, the molecules were formed after the Big Bang. The second generation star, the third generation star. All right. Any more to ask, Derek?
Very fascinating. That's it. Thank
Okay.
you.
Okay, we continue. All right. We continue the next one. October the 14th. No, the 13th. Again, another one. So this one you have seen before. I usually like this type of picture. Why? Wait. By our Sam Okesel from Turkey. All right. You know, as an amateur astronomer in Turkey, you are so lucky. Why? Places like this. So this is the ancient tomb of the Phrygian people. Remember, Turkey got an ancient civilization, no? As ancient as the ancient Egyptians in Egypt. And this is the tomb of the Phrygian. And there you saw the night sky with Andromeda Galaxy, the Pleiades, and Mars. So nice. All right. So this is a beautiful one. And you see carefully here, there are two lions here. So actually, if you were to read astronomy, there's now a very exciting field. We have some of the experts in Malaysia, archaeoastronomy. By studying the tombs in a civilization, of course, for the Marshall England, what Stonehenge law. All right. In Mexico, you have the Mayan tombs law, the Inca ruins law, in Peru law, and all over the world you have ancient tombs. So this is the case for Turkey, and this is very nice. All right. So this is our culture, history, and astronomy. And you know, astronomy, archaeoastronomy, interesting. Why? There are many cases in world history. Of course, there are cases in China also, lah. But there was another one is Alexander, who was a Macedonian king, on the way to attack Persia. All right, he and Darius II were supposed to have a big battle, you know. And then just before the battle, they saw an interesting event in the sky. I think it's a solar eclipse. So they stopped fighting for that day, lah. Maybe postpone the battle. Similarly, when Genghis Khan invaded the Muslim world, also there's going to be a big battle. They're going to lay siege to a city, going to bombard and go into the city. Again, another solar eclipse. So they were very worried. So all these are interesting, you know. So this is astronomy. So the moment I saw this thing, I said, wow, must show this picture. The next one, must show, there you are. Now, again, for the Persians or the Iranian, this is the tomb of Cyrus. Remember, Cyrus is the first king that united Persia, no? Cyrus. The tomb doesn't look grand, but he was the founder of the Persian dynasty, all right, the Achaemenids. And here you have the Milky Way, and this is the tomb of Cyrus, all right? So in other words, you can relate astronomy with history, all right? That's it. We go to the next one.
Can I add something really quickly, please?
Please.
Because I like this picture. I'm like you. I like this picture, and I think a big reason is for anyone who is interested in observing the night sky. This is like a fascinating region to observe, right? The
Yes,
Pleiades on the left, the Andromeda Galaxy on the right, Cassiopeia is right in between. There's that little cluster of stars, which is NGC 752, and this Cassiopeia has lots of clusters to look at. There's a what's that? I call it a flat cat, but it looks like a cat that was run over by a car. But I think they call it the owl cluster or something too. Yeah, very nice place.
Very nice. So, like what our Derek reminded us also, remember TWAN, the world at night. All right. Many of the famous amateur astronomers, they don't use telescope, a camera, Milky Way, and also sometimes with a historical landmark. All right. For example, Barbara Tapreshi. This one, by the way, the tomb of Cyrus is in Pasar Gade. It's somewhere in central Iran. The earlier one was in Turkey, but this is in Iran. All right. So many of the famous astrophotographers will take picture of the Milky Way with interesting object, with meteor shower, with a famous historical landmark. This is the tomb of Cyrus in Iran. All right. So we go to the next one. October the 12th. No, we saw before. Okay, October 11. Well, I make it bigger first. No, never mind. I'll read that for you. Milky Way over pinnacles in Australia. Michael Goff. Okay, I've been trying to check with Michael Goff. I think, sorry if you don't mind, we just look at his face. He look like Malaysian, you know. I checked. I couldn't find which country he is from, but at least you can see his face. Wait. Slowly. A small page. I want a bigger page. Wait. There you are. That's Michael Gore. But I checked it could be either Malaysian or Singaporean, but I couldn't find details about him. And he's a well-known astrophotographer in Perth, West Australia. All right. So he went to a place called the Pinnacle. Pinnacle means ancient rock poking from the ground. That means maybe last time the surface of the earth will reach from the bottom right to the top of this pinnacle, all solid rock, but the water keep on eroding the soft material, leaving the hardened material sticking out. All right. And this is somewhere, it's in the desert, somewhere north of Perth in Western Australia. And you see the Milky Way. All right. Taken by Michael Gore. And then also, it seems here also you can see the so-called, what they call Zodiacal Light. All right. So what is Zodiacal Light? Okay. Zodiacal Light is this. Now, here, this is Milky Way. This is not the what you call this could be the moon, but this is Zodiacal Light. Zodiacal Light is, remember when the solar nebula collapsed to form the sun and the planets and the asteroid and the comet and so on. There are some of the dust that fail to form a planet, fail to form a comet, fail to form the asteroid. So they collect in the orbital plane of the planets. So this is the dust that is orbiting the sun between the orbit of Mercury, from the sun to Mercury, Mercury to Mars, right until Pluto. And this dust, imagine you are an alien far away from the sun, coming close. You are now in Omega Centauri, our neighbor star, coming closer to the sun. You find that you have a bright star and a small object, not the Earth. The small object is a point is Jupiter, and there's a disk. So our whole sun has a ring, a thin ring like Saturn, but a thin ring. And this one is the ring that scatters back the light from the sun to come back to the Earth. And this is the Zodiacal Light. This is not the light of the Milky Way. This is the light from the sun. This the ring of dust orbiting the sun, in between the planets, and come back to the Earth. Beautiful. So some of I like is Michael Gore. He goes to many of the places in the world where interesting natural geological formation. And you take a picture, right? Michael Gore, pinnacles in Australia with the arch of the Milky Way. Very nice, huh? All right. So again, now assume that they are all expert photographers. They don't have to explain the technique now. Just put the picture, right? All right. So we go to the next one. All right. So now we go again. Sorry, I go to the below, so that you can read. Like what Michael mentioned, remember APOD started in June 16, 1995. There's Dr. Robert Nemiroff. He's actually a NASA scientist from MTU, Michigan Technological University. Michigan is a state just south of Canada. Dr. Jerry Bonnell, UMCP, University of Maryland, College Park. Right? Remember, Maryland is the state where you have Washington, D.C. inside. All right. So in other words, it's a state south of New York, all right, and University of Maryland. So if you want to have your picture accepted and published by APOD, these two guys, Dr. Robert Nemiroff and Dr. Jerry Bonnell, will have to approve it. They are the one that every day they approve. So that means for me, I wouldn't like to be in their shoes, because why? Every night we have Kepala Pening, because there are hundreds of people sending very nice pictures to them every day. Like what Michael said, how to choose. So maybe there has a certain rule and regulation. And here also, Philip Newman from NASA will give the rights, certain copyright. So the institution that you work or your individual that you publish, you have the copyright. All right. So this Dr. Robert Nemiroff and Dr. Jerry Bonnell are the ones to decide which are the next picture. So this is our VLA, right? Now VLA is very famous. Is our Jeff Hellerman, a radio astronomer from NRAO, National Radio Astronomical Observatory, AUI in Washington, D.C., and NSF. NSF is, of course, our American National Science Foundation. Remember, in America, you can get your research grant from the various universities and many government departments. One of the most prestigious is NSF. Oh, I got a grant from NSF, National Space Science Foundation, to do this research. whatever research, chemistry, biology, astronomy. So this is a very large array. We know that the very large array is an array of about 27 telescopes, all right, radio telescope, and each of them is 25 meters in diameter on a rail track in the form of a huge Y, X, Y, Z, Y. And the distance between one radio telescope and the next can be changed, such that eventually, from the bottom of this array to the top of the left side Y and the right side Y, it can be about 30, can be up to about 35 kilometers. Remember, imagine you have a square of 35 by 35 kilometers. Penang Island is still smaller. That means the whole plateau in New Mexico, Socorro, New Mexico, is bigger than Penang Island, where this Y formation of the 25 radio telescope can move. So what are they doing? You know lah, VLB, no, it's a BLI lah, long baseline interferometry. So you have one radio telescope here, and the one at the far end is 35 kilometers here, and in between you have another so many of the radio telescope. It's as if the whole square of 35 kilometers square is a gigantic radio telescope. But they don't get an image of the galaxy or nebula. They get an interference signal. So what you have is they will plot the contour lines of the intensity of the radio signal. All right. So this is famous, of course, this VLA is also very famous about 20 years ago by what? Jodie Foster, the movie Contact. All right. So Jodie Foster in the story was a radio astronomer here, where she detected first intelligence signal from a star where there are aliens transmitting. All right. And that story is actually written as a book by Professor Carl Sagan. All right. Turned to a movie. All right. And to Contact. All right. So this is it. So this is a very large telescope, very large array in New Mexico. All right. New Mexico is a state in the southern USA, just north of the real Mexico. Right. So very beautiful. But of course, this is not the more fantastic. The more fantastic what? Remember what they call last year, our Malaysian astronomer, Dr. Kevin Quay, New Horizons telescope, all right, to take the image of the what they call this black hole in the center of M87, first image of a black hole. All right, they use 8 radio telescopes over the whole disk of the Earth. So the whole Earth is used as a radio telescope. Very long baseline interferometry, VLBI, but this is only LBI, long baseline interferometry. Okay, this is our very large array in in Socorro, New Mexico, right? Radio astronomy. The next one will be October 7. I think we exceeded our 9:30. Yeah, sorry, continue. I really like this one. Okay, October 7. This object, greenish blue object, is called U4, OU4. A giant squid. Squid means a sotong lah. A giant squid in a flying bat. So this is the squid, and this is the wings of the bat. Okay, the wings of the bat. And of course, in astronomy, whenever you look at any nebula, any galaxy, anything, you should know it's very big. Right? Now this one, many years ago, I will ask this question when we give talk in Penang. All right, but now I won't ask them because they know is how big is this object. Many years ago said, sir, this is USM law, and this is a Penang ferry lah. I think cannot be. This one could be half a light year. The whole thing can be 1 light year. So big one lah. So this object is huge. Trillions and trillions of solar systems can be embedded. So basically, it's taken by Yannick Akka. All right, Yannick Akka is actually an amateur astronomer from Germany, right? And then they never say what he did. So basically, he must have used a good telescope in the dark location in Germany to image it. So basically, this is only discovered recently. But the bat here, the red part, was of course discovered earlier. So here we look. So this green blue object is called OU4, and the bat here, the cloud is called our SH2-129, known as the flying bat nebula in Cepheus constellation. All right. Cepheus means the king of Ethiopia in the northern sky. All right. So it composed of 55 hours of narrow band data in a telescope view of 6 degrees. So here 6 degrees, no, 3 degrees, 6 full moon can go inside here. And there's so much information. So in other words, it took so many hours, you know. How many hours? Many hours. 55 hours of narrow band. So narrow band could be, what is it? One filter is in blue for oxygen line. One filter in green for hydrogen line. One filter in red for sulfur line. It's not really line, no, narrow band, you know. So you can do narrow band imaging. Nowadays, with narrow band filter, we can get quality pictures like that, not very far away from a city center. Last time you might go to a real ulu place. Maybe in the whole Germany, you cannot find a place so dark. But with narrow band filter, the 3 narrow band in RGB will block off all the pollution from the other wavelength. Only the line in oxygen, hydrogen, and sulfur can go through. And you can get narrow band imaging. So he could have taken this. He never mentioned which part in Germany. He could have taken in a place where there's still some light pollution, right? Not too bright. And the 3 narrow band filter will block off the light pollution and only allowing the 3 wavelength from actually this nebula to go through. Very nice, all right? So this is our sotong in a flying bat, all right? Continue. 6. That comes to the end now. This one you must show. All right. So this is October the 6th. Jonathan T. Grayson. Jonathan T. Grayson is from California. All right. Astropolars from California. The moment I look at this, I always think of William, you know. Why William? Weilun now. William Chin Weilun. Why? Because many years ago, 2003, William sent to me a picture like that, but that is for 2003. So remember, the recent close approach of Mars was Mars closer. And sorry, this guy Grayson is a bit lazy. He didn't continue. But because this is our October the 6th, so he missed it. Because October the 6th, it was Mars closest approach to the Earth. So he had taken Mars closest approach to the Earth, he would have seen a bigger Mars. But I don't know, maybe from California, Mars was not visible, all right? And then that was October the 6th. Then October the 13th, Mars opposition. And Mars is vertically overhead at midnight. So you see here, from 3rd of March, 9th of May, and so on, bigger. Wow, very nice. So this shows that every 26 months, there's a close approach of Mars. So when you say close approach of Mars, what's happening? Actually, what's happening here? Because Earth is the second planet orbiting the Sun. Mars is the 3rd planet, the outer planet. So imagine when the Earth and Mars orbiting around the Sun, as on a big, let's say, the big stadium, right? A jogging stadium. So Earth is on the inner lane, the second lane, orbiting, going around the center of the stadium. But Mars is on the outer lane. So Mars is on the outer lane, going slow, because the Sun's gravity is weaker. But then Earth is closer to the Sun. Sun gravity is stronger. So Earth will overtake Mars on 6th of October. Then Mars will be very big. Very nice. So I remember I reminded William, William, please send me a picture for the recent approach, what he did to us in 2003. Remember, 2003, we had 1 week, we call it Mars fever in Island Plaza shopping complex. We observe Mars every night there, you know, right? And after that, Weilun from KL sent to us a picture like that, including the closest approach. All right, he sent to us, and I sent the soft copy to my student in USM email, and I asked every student to print William's poster of the Mars closest approach. So very nice, huh? Jonathan Grayson from California, Mars closest approach. All right. So now we continue. 3rd of October. Now this doesn't look much, but it's interesting. 3rd October, driving to the Sun SDO, Solar Dynamics Observatory. Remember, the most powerful telescope in space observing the Sun is Solar Dynamics Observatory by NASA. Remember, about 9 years ago, we did a big NASA event in USM, you know, and two of the NASA scientists came to USM. One of them is the team leader, Dr. Jaya Bajpai. She actually was one of the scientists working on SGO, right? So basically, this is not the sun in visible light. SGO studies the sun in wavelength shorter than visible light. So this is even shorter than ultraviolet. So this is shorter than ultraviolet. So you see here, and of course you see this thing poking out here. That means here is the sun's north pole, where the sun's magnetic lines are poking out. Here the sun's magnetic lines are poking out. Here they are not poking out. So these are the equatorial region. No? So basically, what is this? I like to do this because we want to relate astronomy to people in our everyday life. Okay. Question: how long would it take to drive to the sun? So somewhere in America, there are 3 children now. Brittany, age 7, and DJ, age 12, pondered this question over dinner one evening. James, also age 7, suggested taking a really fast car, racing car, while Christopher, age 4, so five children, eagerly agreed. Then 6th one, Jerry, a really old guy, this is an older guy, who is used to estimating driving time on family trips based on distance divided by speed, offers to the numbers. Let's see. The sun is 150 million kilometers away. If we drive 150 kilometers per hour, 150 kilometers per hour, the trip will take only 1 million hours. So if you travel 150 kilometers per hour, it will take you 1 million hours to reach the sun if you go in a straight line. All right. So basically, it's how long will it reach? So actually, 1 million hours is slightly less than, it's more than 1 year. So if you drive 150 kilometers per hour, it will take more than a year to reach the sun. So this will show how far is the sun. So this should relate to the young people, right? So the next one is for the moon. I like it also. So that one was in America. This was in UK, United Kingdom, October the 2nd. All right. Wow, the moon and a guy cycling. All right. Susan Snow. Now Susan Snow from Cheltenham. She's not an astrophotographer. She's just a landscape photographer. She photograph landscape with the camera, and then she will do it. So basically, what you do is this: there's a guy in England riding on a bicycle on a hill. All right. And this is not near, no, far away, Susan Snow put her camera through a telescope. So in this case, because of the magnification, the moon looks big, no, and the person looks small. No? So like this, you cannot get it with your camera unless you have high magnification. So you put through a telescope, this person cycling on the ridge and the moon. So basically the same question asked. How long will it take the person on the bicycle to cycle in a straight line to go to the moon? Well, remember, let's say you cycle at so fast. They say that if you compare with the Tour de France, remember now don't have Tour de France, COVID lockdown. Every year in summer, Tour de France, there are crazy people who cycle 3,500 kilometers all over France and nearby countries, right? And they will take about 87 hours. So basically, they say that in 10,000, in what they call 3,500 kilometers, they travel at 40 kilometers per hour. So imagine you cycle at 40 kilometers per hour in a straight line, go to the moon. How long will it take? It take about 416 days. So you cycle in a straight line, 40 kilometers per hour, non-stop, 410 days, more than 1 year will reach the moon. Very nice. So in Malaysia, they are taking pictures like that. The moon, and somewhere there are a lot of trees, and the best is just a house here. So everywhere, if you travel anywhere in Malaysia, you see a tall hill. So you tell yourself, the next time when the sun on the moon either rise or set, and you see the sun will pass above the top of the hill, above the house, then you take a picture of the house. Even better, make a handphone call to the person in the house, all right? Come out, all right? And take a picture of the person next to the house, and the person holding the hand of a second person with the sun and the moon behind. Very nice, all right? Of course, if you are to make the what they call this person, all right, what they call even closer and closer to you, if the distance between the camera and this person on the bicycle is closer, then the person will be big. The moon is still the moon doesn't change the size. if the person is closer to the telescope, then the person is even bigger, even nicer. All right. So I like to explain this type of picture. So we continue the last one, Michael.
Yeah, sure.
Interesting. Okay. Wow. Okay. That doesn't look anything great, but what great is the name? Damien himself, Damien Fish. All right. I remember Damien Fish became famous more than 20 years ago when he was just a young amateur British astronomer, astrophotographer. He took the pictures. At first, not so nice, but now he's a very famous one. He took a lot of pictures. So with his telescope, you can see Mars, and also this is about Solis Lacus, the eye of Mars. So this is the eye of Mars here, the eye of Mars. So remember Mars, a lot of features. So you can see here the shrinking southern polar ice cap, which is mainly of dry ice, dry frozen carbon dioxide, shrinking. So this is shrinking. What do you mean by that? Then this should expand. No? So right now you have the clouds. Later on you have the northern polar ice cap. So now this is the southern winter, northern summer. All right. So later on you have the northern winter, southern summer. So Mars is like Earth. Mars also axis of rotation is tilted similar to the Earth. All right. And because of the tilt in the axis of rotation, and Mars also has a thin atmosphere, so Mars also got seasons. All right, seasons. All right. So you say here you have the eye of Mars, which is called the lake of the sun. So this is in Latin, Lacus Solis means the eye of the lake of the sun, or the eye of Mars. So very, very interesting, very nice. So I think that's about all. Michael, is there any other picture? Any other comment?
No, there are no other questions.
Okay, just one more comment which I want to add on what I said last month. I'll say again. Why Mars is so exciting? We know as we are speaking, why? Hope mission sent by United Arab Emirates on the way to Mars enter into Martian orbit only early next year. Tianwen-1, launched from Earth on the way to Mars, will enter into orbit around Mars in February next year and land a lander on Mars. All right, and the lander, and from the lander, you have the Chinese rover will come up from Mars and explore Mars. And at the same time, recently, NASA launched their Perseverance rocket, all right, with the Perseverance rover to enter the orbit around Mars in February next year and land a lander called Perseverance on Mars, all right. And this will be, so basically what? Traffic jam to Mars lah. So get ready, everyone. Next year, February is going to be a very hot month. We see when it's going to land. If it lands successfully, so we are waiting lah. So basically, the Chinese Tianwen lander rover and the American rover, they are going to find not only conditions suitable for life. That is the earlier rover. Our Sojourner in 1997, 1996, our Spirit Opportunity early 2000, and then Curiosity some years ago, they found that Mars got liquid water previously, confirmed, right? So Mars is still suitable for life, there's no doubt. So this Perseverance and Chinese rover is actually to see proof whether there is life or not. Got bacteria, got organic material on Mars or not. So this is very interesting. And of course, everyone is now, what they call, wringing their hands. What? They are going to launch their Ingenuity helicopter on Mars. NASA, Perseverance, they're going to let go a helicopter and fly the first, what they call, powered flight on another planet called helicopter. So very interesting, huh? So Mars, everyone. Now, why is it Mars interesting? Remember, old story lah. Sometime in the 19th century, the Italian astronomer looked at Mars law and they found certain lines on Mars. So they said, the Italian call it the canali, C-A-N-A-L-I. So in Italian, canali means channel, a natural place for the water to flow, canals lah. No, channels of water, a canali. But later on, the Percival Lowell, a British businessman in New England, America, he used his telescope in New England to see Mars, and he thought he see lines, all right? And you know what? Imagination, no, went twisted the meaning. So canali channels in Italy become canals. CANAL, canals in English. So there was a fever. So then he invested and built his Lowell Observatory in Flagstaff, Arizona. And he went there and he found that with the big telescope there, a lot of canals. So then when he drew the canals, the American and the Australian in Europe all were fascinated. So what? Mars fever, Martian, Mars got life. So from there they say Mars got life. But unfortunately, sometime in the 1970s, America launched their Mariner flyby of Mars and took close-up picture of the Mars surface. No canal, no alien, all right? No aliens there. So now they don't know Mars. But now Mars has been in the human imagination, especially now they have found got liquid water on Mars. So everyone interested to look for Mars, life on Mars. Of course, other places in the solar system, even more interesting are Europa, Ganymede, Callisto, right? Where they have confirmed that below the frozen ice, thick ice, liquid warm ocean of water, liquid water, all right? Below the surface of Europa, Ganymede, Callisto. And also the recent discovery of phosphine, all right? PH3, phosphorus atom with 3 hydrogen atoms attached to it in this molecule, in the phosphine found in the atmosphere of Venus. And phosphine on Earth, all right, is only emitted by living organisms. So people are very exciting. But I think in the past month, some research results came out that they misinterpreted the data for this what they call phosphine on this atmosphere of Venus. Actually, it was not phosphine. It's some other process that can be explained. So now we don't know whether it's confirmed or not that's phosphine or not. So we have to check. But if it's confirmed later that there is phosphine, that means it's interesting to study looking for life on Venus also. Okay, so I end now to today. Any question, Michael?
No,
Dr. Chong, please allow me to add on a bit.
Sure.
Just now you mentioned about there are 3 missions launched this year, correct? I did mention about that just now. Add on is when we talk about Tianwen, we say February it will approach Mars. So for February 2021, we will have orbital insertion. That means it will go into Mars orbit. Remember, Tianwen is a 3-in-1 mission. So we'll have a lander and a rover mission.
Sure.
So after it reaches Mars, starting orbiting Mars, it will take about 2 to 3 months of orbiting Mars, orbital mission. And then the landing is expected to happen on May next year. So keep an eye on it, May. All right, so that means it will first reach Mars, it will orbit Mars, and then look for suitable landing spot. Because currently they have 2 options, and they haven't have a final decision which is the final landing spot. So they will have the orbital mission, they will go around Mars, and then 2 or 3 months later, expected May, then they will land their Tianwen satellite, the Tianwen spacecraft on Mars, and then the rover.
So thanks for the reminder, Lai. So actually, it's orbital insertion in February, but only will land in May, all right? But then as I said, I think when the Tianwen was launched, we covered it live. Is that for the China, it's going to be 3-in-1 jiabei no?
Yes, 3-in-1.
Remember the Americans, the first time the Russian and the Americans just fly by on Mars only. That means fly by Mars and go away into the outer solar system. But China is going to do the impossible. They're going to go into close to Mars and orbital insertion on Mars. If they can succeed, big success. Okay?
Yes.
Then later on, they're going to occur. They're going to take a close-up picture of the landing site, and then they'll decide when to drop the lander with the rover inside there. All right. And until now, I don't know what is the principle. Are they using the airbag principle to land the Martian rover, the China?
They have the airbag and the anti-thrust.
The airbag and the anti-thrust, because the rover, America using the sky crane, patient sky crane, isn't it? Yeah. So this one is they're using the airbag and the last minute firing of retro rockets, all right? Now that one you can land, big achievement, The third one is, and then the China rover come out, and then you see the tracks on the surface of Mars, the third one. So they're going to do 3-in-1, So I tell you, it's going to be a big task, So if China can do it, it'll be a great. So nobody has done all 3-in-1 at one go. So this is we hope, we all hope. All right. So it'll be very great. So that means America will launch will land in February, the rover. So the first pictures of surface of Mars will be in February, the American rover.
Yeah.
Then only in May, the data from the China rover. That will be interesting. Oh, very interesting. So next time, get ready. You hope that Mars will still be visible at night from Malaysia. And we do stargazing there, boys and girls. Can you see the Mars 2 rover or not? Can you see the UAE orbiter or not? Tell them to go and read up. So very interesting, Derek, Now they are trying to find confirm that there are past life on Mars. And the American mission, they already got all the capsules ready. They put all the Martian soil into capsule, hoping 10 years later another American mission go and bring back the capsule back to the Earth in, I think, 2033, right? 13 years from now. But China, in this present mission also, Tianwen, they also put the Martian soil into the capsule, but they never mentioned when they're going to bring a second Mars mission to Mars and retrieve those capsules with the Mars sample back to the Earth. So that would be very exciting, Oh, yeah.
Okay,
Yes,
so
Most definitely.
Dr. Chong, can you click on the stop presenting on your screen?
Okay, I stop presenting.
Yeah. Okay. So, okay.
Yeah, and-
Before.
And
Yeah,
before the very final comment from me is, we have gone through quite a number of interesting, beautiful images today, photos today,
Yeah.
and the only final word from me is, the last comment from me is, we should appreciate all these photos, and because there's a very bad news is we know that SpaceX, the very famous company, is launching a lot of these Starlink satellites, mini satellites. And we already have astrophotographers complaining about the effect of this Starlink. So we have extra star trails when you do astrophotography. So this is something not good. And this is not the worst part. The worst part is actually, I read yesterday, the statistics shows that they have launched up to now is about 856 satellites, and there are 3% of failure. That means there are 3% of this 800. That means there are about 20 satellites up there is not functioning. So this actually creating a lot of space junk and impose a big problem for in future the aerospace industry as well. So I think we should appreciate the good time now, take more photos, right? So that's
Let those
probably,
space junk crash into each other.
Actually,
yeah.
actually,
And the scary thing is actually it will be like a chain reaction. If one of these hit the other, and then it will break into smaller parts, and all this will not come back immediately. It will round the Earth, orbit the Earth for a long time, and more satellites will be affected. So this is something very, very bad.
So a bit of a background, Derek. I remember about 20 over years ago, the American advertisers, I think maybe Coca-Cola and so on, they want to launch big advertisement in space. That means they will send up in the rocket orbiting the Earth and open a payload with highly reflective nature, maybe forming a big Coca-Cola sign in the space, 300 kilometers space orbiting the Earth, and other companies. Many of the people in the world, including probably astronauts, no, cannot. The American government back off. That was a big hue and cry, But I don't know why quietly, why the FCC, the American Federal Communication Commission, give permission for SpaceX to launch all the Starlink. Do you know what they are launching live? They are launching in the payload of the rocket a bus,
Yeah.
A bus, 1, 2, 3, 64 Starlink. So every time the Lego 64, like throwing out into space, kacang putih, So eventually, tens of thousands, maybe 50,000, not 800, 50,000 Starlink. Bye-bye astronomy, bye-bye.
I read they said they are planning to send 12,000. So
Maybe more. Because you see,
initially when I say 3% of failure is actually a very low rate, it sounds good, because if let's say you launch 100, only 3 fail, sounds okay. But then if you imagine this is 12,000, that means there are about 360 failure, 360 junk satellite up there. So this is
300, yeah, correct. 360. Yeah.
This is very scary, you know.
I am very sure that some years ago, when the FCC got the application by SpaceX to launch the Starlink, many of the organizations like what they call this big observatory in the world, they protest, but the FCC just ignored them. So I have a feeling there's something very, very controversial going behind FCC, NASA, and Elon Musk. Something not correct. Cannot
Sensitive and confidential.
20 years ago, 20 years ago, they want to send Coca-Cola exhibition in space, And remember,
they're still trying now. They're trying to launch a microsatellite. They're trying to launch a microsatellite that has this, advertising display now that fly across the sky, which is ridiculous. Yeah.
Those microsatellites are much lower than the orbit of the ISS. They will decay one. But I don't know how high are these Starlink. If Starlink is higher than ISS, they will remain there up to thousands of years, So I don't know why. There's something strange going behind. So this, I have a feeling that this our Elon Musk is given very, very special treatment. And the other one, remember, big news, that those days don't have internet. 1980s, late 1980s, Russia sent up a very big spacecraft where it opened a highly big reflective layer, So don't know how 100 meters by 100 meters. So they reflect because they're in winter in Siberia, 24 hours nighttime. So you have sunlight will go above the horizon, hit the big reflective this mirror in space, and beam back onto the Earth, so they become daytime for some don't know how many minutes. They did that, no? They succeeded. The Russians succeeded. But some people say, do it some more, but they stopped. They have tested the technology. And of course, the other one is even got 1960s Vietnam War in here. That time I was just reading about astronomy theoretically. The American military said that they want to launch big mirrors in space, orbiting space, so that at night the jungle, the Viet Cong hiding in the jungle, so they cannot run away at night. The light from the sun, we hit the convex mirror in space. You go down to the Earth and burn them in the jungle. No, that was a big. We read about that. The military talk about that, 1960s,
Yeah.
Yeah.
Yeah, but I think that now a lot of the scientific data come out about the negatives of lack of darkness in nature and even for us humans. And more and more scientific evidence is coming out that it's a direct contributor to a lot of ecological problems. So I think that this will be the only, and actually the most critical fight against all these nonsensical light pollution ideas. So it needs to be pushed a lot more. This needs to be more responsible.
So like what Ryan says, correct Quickly, quick. Wait another 3 years. Every night gone already.
Yeah, so, take more photos and send to us.
So artificial star trail.
We give a hint to those software developers. Come up with the software. When you get this Starlink star trail, your software will delete those star trail. Those Starlink star trail. Delete them. Leaving the natural star and the galaxy there. Terrible.
Okay, all right. I think we shall stop for today.
Thank you, Derek.
Okay. Before we end, thank you, Dr. Chong, and thank you, Lai, for your presentation. And also thanks to everybody for joining us tonight. We're going to close the session today. So hopefully we'll see you again next month.
Sure.
All right. Good night, everyone. Thank you for joining us.
Thank you, everyone. Bye-bye.